So in this video, I'm going to go over the quizzes and that extra one that I did at the end. So circle the choices for the congruent and transformations that occurred in the graph. Determine whether the polygons with the given vertices are congruent. State why or why not by circling the correct transformation. Well, when I look at these points, first of all, I see that I have that if I look on either side of y here, that the points look the same. So if I go 2 away to the right and 2 away to the left, and then this point is obviously on that line of what I think is the line of reflection. And down here, this is 3 to the left, and this is 3 to the right. So just by looking at the graph, I would know it's a reflection, but I could also write the rule. The rule for our reflection over the y-axis is -x comma y, and notice that all the signs for the x's changed, except for the 0, obviously, because that can't change. So I say that this is a reflection over the x-axis, and that they were congruent because reflections produce congruent images. And if you recall, the 3 that do are reflections, rotations, and translations. Number 2 in this quiz says put the answers on the line. No work, no credit. State the reason or theorem on line 5 on the line. So find if try and KLM is congruent to RST, and what is the value. So if they're congruent, then we know that KL is congruent with RS. That means that we can set those two things equal to each other. So that would be 4x minus 3 equals 9. I'm going to add the 3 to both sides, so that's going to be 4x equals 12. I'm going to divide by 4, so x equals 3. So that was our answer, 3. And the reason is because we had two triangles congruent, then we know that all their parts are congruent. So this was CP, TC, and the way I told y'all to remember this was 3 C's PT. With number 3, it says find the measure of angle D. Well, on this one, I know that angle C plus angle D is equal to angle DBC. Or sorry, DBA, my bad. So when I add this angle plus this angle, it equals this exterior angle. That's what I know. So I'm going to say 3x plus 4x plus 5, that equals 75. So I'm going to combine my like terms. 3x plus 4x is 7x plus 5, that equals 75. I'm going to subtract 5 from both sides. So that's going to give me 7x equals 70. So x equals 10. Now this time it doesn't ask me for the 10, it asks me for D. So that means I got to plug it back up in here, this one right here. So that means I'm going to do 4 times 10 plus 5, so that's 40 plus 5, and that's equal to 45. So this was 45 degrees. And the theorem that we used here was the exterior angles theorem. That's the theorem. So number 4 and 5, it says show your work in the box with the picture, state the theorem, and explain the process used using vocabulary terms. So here it says find the measure of M and Q. Well, because L is congruent with P, L is congruent with P, and K is congruent with N, we know that M is congruent to Q. And the reason we know that is by the third angles theorem. So the theorem should have been the third angles theorem. Okay, so what does that tell me? That tells me that 6x plus 10 is equal to 7x minus 2. So we would subtract 6x from both sides. So 6x minus 7x is x. We would add 2 to both sides. So that would be x is equal to 12. And then it's telling me to find the measure of these two angles. So I have to plug that back in. So the measure of angle M is equal to 6 times 12 plus 10. That's 72 plus 10, which is 82 degrees. So that's the measure of angle M. And then we've got the measure of angle Q, and it should be the same, is going to be 7 times 12 minus 2. That's 84 minus 2, which is also 82. So the measure of angle Q was also equal to 82 degrees. So then it says explain using vocabulary. So we would say that angle M is congruent, or you could have said equal, to angle Q because of the third angles theorem. So for number 5, it says if you have a triangle, then find the measure of angle L. So here, there's a couple ways you could have done this. First of all, this would have been the triangle sum theorem. Be good if I could write triangle sum theorem, okay? So we could have said that angle L plus angle N plus angle M equals 180. Also, we could have done that by saying angle L plus 38 plus 90 equals 180. So angle L plus 128 equals 180. And then we would have found angle L equals, what is that, 52 degrees. Okay, but the other way we could have done it is we could have noticed that this was a right angle and it was used, so we could have just said 90 minus 38. That also equals 52 degrees. Right? Yes. Okay. So what would we say here? We would say that the sum of the three angles is 180 degrees. So add all three and subtract constants from 180 to get 52 degrees. So first of all, I want to bring to your attention that I had two different versions of the quiz. I had the bullet version, and then I had another version. I can't remember what it was on it, but I'm going to go through both of them. So I've got side, 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 angle, side, angle, side, angle, 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 side, and HL. Those are our 5 ways of proving congruence. Number 6 says in order to prove two triangles are congruent by HL, they must be right triangles. Now I'm going to go through these drawings on these next 9, and I'll go through them also on the other version. So it says that we need to write the theorem here and write no if they cannot be proven. Now remember that we should always mark the things that we can mark in each drawing. So on this first one we can mark the shared side. So this one's going to be side, side, side. And we're looking at tick marks and arcs, remember. On this next one we can also mark a shared side. However, this time we get SSA or ASS, and that's no because that's butter but backwards. Our next one, we have another shared side here. I notice that these are two right triangles, and we do have the hypotenuses, and we also have an additional leg. So this one's going to be HL. Our next one, we have angle, angle, side. Number 11, we have a shared side. We're going to put a tick mark on that. So we have angle, side, angle. On the next one, we have vertical angles, so we're going to go ahead and mark those with our arcs, showing that they are congruent. And again, we have angle, side, angle. So number 13 for version bullet was side, side, side. 14, again, we could have marked the vertical angles. So this is going to be side, angle, side. And 15, we can mark the shared side. And we can mark these alternate interior angles. So this is going to be side, angle, side. All right, now on this one, and again, if you're looking at this from someone else's classes, my versions of the test or quiz were a little bit different than y'all's for some of the questions. So this one, so we have that BAC and angle AB, CB, CA, side AB, CB, and CA, and then we're trying to talk about a triangle congruence. So the very first thing I'm going to do is I'm going to put some arcs on these angles, and I notice up here that between this two tick mark and one tick mark, I have angle B. So I'm going to look for the same thing on the other side. So I have 2 and 1 here, so that's going to mean these angles are congruent. So B and Y are congruent, so I'm going to go ahead and say angle Y here. And then let's go ahead and look at angle A. That's between 2, notice the 2 here, and the 3. So we're looking for 2 and 3 over here. So we're going to put 2 arcs here and 2 arcs here. So that would be X, angle X. And then with C, we're going to go ahead and put our 3 arcs because the only thing that's left, which means Z. So that's the only thing that's left. So we got angle C is congruent to angle Z. So now, what I like to do is go ahead and write my congruent statement, if you remember. And this should be pretty easy now because we have which angles are congruent to which angles. So notice that C here maps to Z. So we're going to put Z first because we have C first there. And then we've got B up here, and that would be Y. And then, of course, A is equal to X. So now when we look at these congruent statements, AB, I want to show you something. So AB right here is right there. So that's going to be then XY. So we're going to put XY here. When we look at the next one, again, because we already have our statement written, it's CB, so those were the first 2 letters there, which are going to be the first 2 letters here. That would be ZY. And our last one is going to be CA. So that would be first to last. So over here it's going to be first to last, ZX. Sorry, and I forgot to put the line over the one up here. So that's our congruency statement and our congruent statements for various different parts. So number 17 says find the value of X so that the triangles are congruent. No work, no credit. Well, I know that this side is congruent, and if I'm trying to prove congruency, I would probably try to do that by side, side, side. So that means my third sides have to be congruent. So that means I can say 20x equals 22x minus 3.6. So I could go ahead and subtract the 22 from the 20. That would make me negative 2x is equal to negative 3.6. I will divide both of these sides by negative 2, so x is equal to positive 1.8. And that was our answer. So if you had the bullet version, then you should have watched the prior part of this video. If you have the pound version, this is the one. So, I mean, all of these first answers are the same. Side, 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 angle, side, angle, side, angle, 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 side, and HL. And remember, we never use 2 S's next to each other unless it's side, side, side. Number 6 was, again, in order to prove 2 triangles are congruent by HL, they must be right triangles. So again, we're going to write the incongruence postulate to prove that the triangles are congruent unless we can't. So here again, we're marking our vertical angles. So we have side, angle, side. On this next one, we are going to mark the shared side. So this one's going to be side, side, side. The next one, again, we're going to mark the shared side again, and we have a pair of parallel lines, so we can mark our our alternate interior angles. So here we go again with side, angle, side. Number 10, we can mark our shared side here, and this would be side, side, angle, which again, we don't use but backwards, so this one is going to be no, because it was side, side, angle, or angle, side, side. On this next one, we have angle, angle, side. And this one over here, again, we're going to mark our vertical angles. So then we have angle, side, angle. Number 13, side, side, side. Number 14, we have a shared side. And then notice again, we have the right angles here. So we're going to check and see if we have HL. There's our hypotenuse. There's our hypotenuse. And we do have another leg. So this is HL. Remember, the hypotenuse is opposite the right angle. Here again, we have a shared side. So we have angle, side, angle. Okay. So this one we already worked on. The other one, but I'm going to do it again. We have a shared side here. Then these sides would be congruent. So that would be 20x is equal to 22x minus 3.6. Subtract 22 from both sides. That's minus 2x equals minus 3.6. Divide both sides by negative 2. So x is equal to 1.8. And the way we would have solved this is with side, side, side. So on the next one, we have complete the congruency statements. What I'm going to do again is I'm going to put some marks on these angles. So notice we've got B here, so I'm going to look at B here, and it's between 1 and 3. So over here I'm looking for the angle that's between 1 and 3, and that was M. So that was M here. So this would be angle, this would be angle M. Then we've got A, and A is between 1 and 2. So we're looking for what's between 1 and 2 on the other side, and that's angle L. So this would be angle L. And then angle C over here, we're going to put 3 arcs on it, which would be K. So that would be angle K. And again, I'm going to jump right down here to my congruency statement because we've got that C maps to K in our angles up there. Then we've got B. B up here maps to M. And then we've got A, and A maps to L. So once I have that statement, I'm going to use it to write my congruency statements. So I've got AB right here, notice that. So that's going to be last and middle. So that's going to be LM here. Then we've got CB, those are the first 2 letters, so that would be KM. And then we've got first and last, so that would be CA, KL. So we're going to go over this other one we did as well. So again, with number 1, we have a pair of vertical angles. So we have side, angle, side. On this one, we have a shared side, so we're going to go ahead and mark that. Notice we have 2 right angles here. And again, we have the hypotenuse, which is opposite those right angles. So this is going to be HL. Then we have vertical angles here. So we have angle, angle, side. On number 4, we have a shared side. So this is going to be side, side, side. Remember, tick marks mean sides and arcs mean angles. Here we have angle, side, angle. Number 6, we have side, side, side. Seven, we have a shared side, and that would be side, side, angle. And if you remember, we don't have 2 S's next to each other, so this would be no. They're not congruent. And this one would be a shared side there. So we have side, angle, side. Here we would mark the vertical angles again. So this would be angle, side, angle. Number 10, mark our shared side, angle, angle, side. Number 11, mark our shared side and then our alternate interior angles here. So this would be side, angle, side. And then number 12, mark our shared side. Notice here again we have two right angles. We do have the hypotenuse because that's our shared side, and then we have another leg here. So this would be HL.